Thanks, Dean, and thanks to you and Ray for walking through all that good information on concept of operations and some of the design considerations we need to think through. Actually, that conversation, that discussion that you two just led helps a lot as we move forward into this next topic. Makes my job just a little bit easier. I'm going to talk about costs, procurement, and corridor selection. I'm actually going to talk about them in the reverse order of that because I think that makes a little more sense. So we'll start with some idea about corridor selection. When you as an agency have decided to pursue the SPaT challenge, the first thing you need to figure out is where to do it. And I think there are really a couple of considerations to be given as you think about where to do it. The first one is an infrastructure compatibility decision. And it's really a fairly basic set of criteria. We need to get SPaT data out of signal controllers, and that's a lot easier to do if your signal controllers are fairly modern. And so as you look at an infrastructure corridor where you can deploy SPaT and map, I would encourage you to pick a corridor where you either have relatively modern signal controllers or are about to replace your controllers with modern controllers. It will make your life easier and it will make the project go much smoother. It's also probably not mandatory but very helpful if along that corridor you've got good backhaul from your controllers back to some kind of a central operations system, a central control system for your intersections. It's not a requirement of the SPaT challenge, and you may not see the need in the short term to be able to move data back, but there are a bunch of reasons why being connected can be helpful in the longer term. So that's also a good criteria. Some agencies approach me and say, you know what, I'm not sure I'm ready for the SPaT challenge, but what should I do to get ready for connected and automated vehicles? And I say to them, upgrade your signal controllers and connect them all. I just think that's a good basis for infrastructure that will be useful as we move forward. You also may want to think about the number of signals on the corridor. The SPaT challenge specifically talks about having a corridor network of about 20 signals. You know, we're not real hard and fast about that number. The corridor we've deployed in Utah has 24. Some have 16 or 17. But you want to think that through. You know, if you've got a corridor you're looking at, it's only got 3 or 4 signals on it. There might be a reason why you would use that, but you might want to look around and see if you've got a corridor with more signals on it. That's sort of our goal, is to get a few more of these out there. So that's just something to consider. I think the second basic criteria to look at really rolls up into the concept of operations discussion that we've just been through with Dean and Ray. You want to think about, in a broader picture, sort of longer term, what your local conditions and needs are. Do you own the corridor entirely? Do you share it with some partners? Are those partners that you get along with well and you can have a conducive relationship with as you deploy something like this? Or do you need to look around? And what might your future applications look like? The concept of operations process that we just walked through here a few minutes ago will help you work through those kinds of things. And I think that feeds into a corridor selection. The SPaT challenge is really about roadside units broadcasting SPaT and map data at the intersection. And it's really only about that. But we all know that in the long term we want to make use of that infrastructure, and this is just the first step. So considering those applications is helpful. If one of the applications you're envisioning, for instance, is a transit signal priority application, and you happen to pick a corridor that doesn't have any buses on it, well, you've sort of defeated the purpose. And so you just want to think through where you might go. Admittedly, you might not know some of those things yet, and so you might not have that information to work with. But it's worth some brainstorming and some thinking about what the possibilities might look like. And I think those are a couple of good criteria for corridor selection. Once you've selected the corridor, we would really encourage you to get information to the National Operations Center of Excellence, and you can route that through Dean Dieter if you'd like, but get it to the team, and so we can put a pin on the map for your location. We'd like to give you credit for for starting down this path. We'd like others to know that that's what you're doing, and we'd all like to know about what activities we each have going on. So get the information in, a location, a short paragraph on what your plan is and your timing, and some information on who to contact, and let us get that on the map so that everybody knows what's going on. As you move from sort of the corridor selection toward procurement, we want to know a little bit. It's helpful for you to know a little bit about what the operations are you anticipate and what requirements you'll have in the longer term. And there are several things that are important here. Again, the SPaT challenge is about broadcasting the SPaT and MAP messages. But ultimately, we'll want to be able to receive a basic safety message out of a vehicle. And you may have other messages that you ultimately want to send back and forth based on the kinds of applications that you're going to deploy or plan to deploy in the longer term. It's useful as you get ready to do procurement to know some of those things. And it'll help you make better decisions and write a better procurement document. As an example, for our deployment in Utah, we've actually deployed the MIT software, a version of the MIT software to do conditional transit signal priority. And as part of that application on our intersections, we need to send the signal request message, or SRM, and the signal status message, SSM, back and forth between the roadside unit and the onboard unit. As it turns out, the DSRC devices that we bought don't directly support, at present time, don't directly support those messages. So we had to spend some time figuring out some workarounds to get those messages sent back and forth. If you know that those are the kinds of things you want to do ahead of time and can put those into your requirements document before you procure, you might have a better chance of getting equipment that has some built-in features to accommodate that. And so those are the kind of things you may want to think through a little bit. Performance requirements are also important as we think about the frequency of sending these messages back and forth, and some specifics about the hardware. So some of the applications require that you have two separate DSRC radios. They're both in one container. They're both in one case, if you will. But that allows you to operate on multiple channels at the same time. And for instance, our application requires that. You can buy hardware that does or does not have that feature. And so knowing some of those performance requirements is helpful. Finally, let me say just a little bit about security. We all know that in the long term, we need to secure these messages as they're sent back and forth. And there's a lot of work that has gone on in the last 4 or 5 years working towards secure transmissions. Specifically, a security credential management system, or SCMS, is anticipated to be a tool that we'll all have access to. Currently, the SCMS being built for the 3 federally funded connected vehicle pilot deployments in Tampa, New York City, and Wyoming, is a system that will be temporary. It's really only intended for a few of these pilots and will not be a permanent system. And secondly, it's a system that's not being built to accommodate all of us, and so most of us won't have access to it. There will be some other kind of an SCMS system eventually, and all of that is sort of in the works here. And so most of us can't walk out and attach ourselves to an SCMS system yet. But knowing that it's coming and understanding a little bit about it as you prepare to do procurement is helpful, so that you make sure the equipment you get is compatible with those kinds of systems. Now, procurement is a tricky issue, and there's really nothing constant or consistent about the SPaT challenge. Many of us have different approaches to going about this. And I could go into great detail about some of the procurement challenges that we had as we purchased equipment for our deployment in Utah. But let me say that there's a bunch of different ways we can go about this, and you just need to think through what some of your specific constraints are. I was procuring as a government agency, and as a government agency, there are obviously a number of processes and rules that we need to abide by that are unique to our particular jurisdiction. I was able to procure some small quantities of devices from multiple vendors for testing purposes. And many of us have the ability to do that without going through complicated procurement procedures. That allows us to get our hands on a few pieces of equipment that we can start getting comfortable with, and we can compare with each other if we decide to do that. Going through a full procurement process requires, of course, advertising for a period of time and having a bunch of documents that you can post and that the vendors can respond to. Depending on your specific requirements in your jurisdiction, there may be limits on how you procure. Is it based on cost only, or can you consider performance specifically, and can you buy from multiple vendors or a single vendor? And all of those things are something you want to think through. In many cases, agencies deploying will have a partner, either in a different kind of a government agency, maybe one that's a quasi-government agency like a transit authority, for instance, that might have procurement rules that are a little less stringent, or they might be working with a university that has different sorts of rules and policies, and so you can work through that process. You might also be using a consultant, and it would probably be faster to have a consultant procure those devices for you directly rather than you going through a government process. There might be rules about whether or not you can legally do that, and there certainly would be rules about who owns that equipment in the end, and you want to think through those. So I don't have any great answers for these kind of scenarios because there are so many of them, but I just wanted to sort of throw out the broad range of how you could do this. We've been working on a resource document that includes some sample specifications that you could use in a procurement. We've found, as we've collected them from several different agencies, that the complexity of those documents has a pretty broad range. And for those of you on the call today, if you've procured already and feel like you've got a document that was particularly helpful and useful and would be willing to share that, we would certainly be interested in broadening our list of documents we have available to us and being able to share some of those components out with everyone else. Procurement is an issue we all have to get through, and it's fairly unique, but it's one that's going to take some time, and you need to think through as you move forward. There are several basic requirements that I think are well suited to a procurement document. The roadside units now are pretty well defined in what we call the 4.1 specification, or some call it the 4.x specification because there's a 4.0 and a 4.1. And that document is out there, and I believe it's posted on the Operations Center resource list, and you can get that. I don't think you need to repeat what's in that document in your procurement, but it's certainly a good reference to link to. There are some outside certifications of DSRC documents going on. Much like when you buy a piece of electronic equipment and it says Underwriters Laboratories on the corner in a little logo, there are some similar certification activities happening. And in the near future, we hope to be able to just reference needs to meet this particular certification, and that would be helpful. As I talked about a few minutes ago, you want to specify in your document specific messages or specific performance, specific security requirements that you might want to use in your particular location. It would be very helpful if while you're procuring these units, you also procured a software development kit. We are in a position today where the V2I, the connected vehicle space, is not nearly as mature as some of us are used to in things like signal controllers or ITS equipment. There's still a fair amount of variability. There's still a fair amount of movement going on in the development of this equipment. And off-the-shelf software, off-the-shelf applications really are essentially non-existent, except for maybe some very simple things. Having a software development kit and people on your team who know what to do with it, I think is very important for anything but just a very basic deployment. So I think you should consider that as part of your procurement. You also want to think about whether you want to also purchase a few onboard units. Again, the SPaT challenge is really just about broadcasting SPaT and MAP, and an onboard unit isn't a necessary piece. But I think you might want to know that those messages are going out there and start to consider how you might receive those. And especially if you're looking down the line at some applications, getting a little experience with an onboard unit might be helpful. In a subsequent webinar, when we talk about the verification document that Dean referenced a few minutes ago, as I recall, the verification document requires you to receive the messages sent with a brand of device that's different than the one that sent it. And so at some point you might want to think about not only ordering an OBU that is of the same manufacturer as your RSU, but maybe one from a different manufacturer, and start to play with that. Again, OBUs come with one radio or two, and depending on the applications you may want to think about in the future, you should consider that. Let me move on to, well, you also need, of course, to procure cabling and mounting equipment. And here are just some photos of some different ways that these DSRC roadside units are deployed, whether they're strapped directly to a luminaire pole or on a post that's mounted to a pole or to the signal mast arm. There's a variety of ways to do that. This is fairly simple and routine equipment, but you're going to need to procure that as well. It's powered over Ethernet, so you need to be able to get that cable back to a signal cabinet and have a PoE device in there where you can source power. I list on here a processor. You need to get data out of your signal controller and into the roadside unit, and there are really three ways to do that. And as we run applications in the future, there's really three places where you can run those software applications. One is inside the controller, and some of the controller manufacturers now are starting to sell a coprocessor unit that fits in the controller where you can run these applications. The second option is to run it inside the DSRC device, and there's processing power on most of the late models of DSRC devices where you can run the software there. The third option is in between, and that's the option actually that we've used in Utah, where we've purchased a small Linux board that mounts in a case inside the signal cabinet, and we're doing processing on that board. It's a fairly inexpensive device, but you want to think through that as you go through your procurement, and that might be an outgrowth of some of your ConOps discussions as well. Running a little short on time, but let me walk through some costs real quickly and give you an idea. Before I do that, I'm going to give you a disclaimer. As I mentioned a few minutes ago, this space is not as mature as some others, and what we're finding as we start to look at costs and try to provide some guideline on costs, because that's a question everybody asks, is that every deployment is different, and there are a huge number of variables. Now I'm going to give you some cost ranges, but let me sort of warn you that there are ranges, and there might be even some things outside of the range. There are a lot of factors involved here. The first one is learning curve. If you were like us in Utah, when we started this project, we had no deployment experience with this kind of equipment. And both for me and for my team and for my consultants, there was a learning curve, and there was a cost to that learning curve. If your team has a bunch of experience, that would be different. Are you using a consultant, or are you doing this in-house, or are you doing a combination of those three things? And that makes some kind of a difference, as you well know. Are you going to order some equipment and do a bunch of testing to verify it meets specs, or are you just going to sort of trust it out of the box? There might be some time and expense involved with doing some testing. Are you planning at the outset to deploy some applications beyond SPaT? That's what we did, and so some of the costs that I have are a bit intermingled. It's a little difficult for me to tell exactly what it cost me to do SPaT deployment versus my application, because those hours and that time and those invoices were kind of wrapped together. There are variations on how you procure, and it may be a different price if someone else buys them for you than when you buy them yourselves. And of course, there are some installation parameters, and I'll talk about some of those. So really quickly, and we'd love your input. If you've got some experience with some of these costs and would be willing to share that back to us so that we can kind of work it into the documents we're working on, that would be very helpful. We've struggled with how to present data because of all these variations back to all of you in a way that's useful. We can't just sort of give you a lump sum because we have to define what's in it, and we've struggled with how to do that. So any kind of detailed breakdown you might want to prepare is helpful. First of all, let's just talk about the basic hardware. Roadside units in general, just the raw hardware, purchasing from the vendors. My experience is, and the experience of several others of us who've been doing this for the last year or two, indicate that the roadside units run from about $1,500 to $3,200 a piece, somewhere on the order of the cost of a signal controller, right? So a pretty reasonable number. There are, of course, mounting brackets and cables and power supplies and those kinds of things for a few $100 more, depending on what you do. Of course, if you need a Linux processor, there's another $100 probably in there as well. The onboard units are slightly less expensive, about $900 to $1,500 for one of those units. And again, those are a little variable and they're changing as more people get into the market, but that's sort of the general range. Now the soft costs, or the engineering costs, is where a lot of the variability takes in. And so during your design and testing process of this equipment, you might have a pretty broad range. I list here maybe $1,000 to $8,500. And it depends on sort of what some of that design and testing is. Where is your learning curve? And how many units are you going to deploy? And so if you have a learning curve and it takes your team, a month and a half to figure out how to make the first one out of the box work for you, the rest of them go up fairly simple after you've done that. And so there's some variability to these numbers, but going through the ConOps process, for instance, and figuring out a design, where to mount these and how to mount them, and maybe preparing some documents around there can involve some kind of a cost. Installation and integration depends on several things. One is the location. Are you deploying, as some of my photos showed, on the pole, which would mean you could do it without closing lanes, or out on the mast arm? Do you need to close lanes to do that? Do you need to have night work? And our indication is that the installation cost, once you kind of figure out how to do these, can range from a couple of $1,000s per intersection to 5 or 6 times that, depending on some of those factors. Some agencies have found that they've wanted to go out and do RF surveys of the intersections to know where the interfering radio frequencies are. And in more complicated urban environments, that might be necessary. In less complicated environments, it might not be. Our agency did not do that. Others have. And that cost by itself inside this range is probably a couple of $1,000s. So there's some variations there. And finally, you need to create the map data. And there's, as we indicated, 2 webinars in the future talking about map data. And once you figure out how to do that, there's a cost associated with doing that. It might be on the lower end if you use a tool and your intersections are fairly consistent. It might be on the higher end if you are using some kind of your own mapping data. On one of the projects we're working on now, we're installing the SRC equipment on intersections that haven't been that are under reconstruction, and so we can't use raw map data. We have to use CAD drawings, and so that makes a difference on some of our costs and some of the effort involved. And so you need to consider that. Well, if you were to add these numbers up, as I've shown them on the last couple of slides, you will get something on the range, including all of these costs, of maybe $16,000, $17,000 per intersection, up to maybe $25,000 per intersection. That said, having been through the learning curve, I believe we can now deploy a given intersection, now that we've been through a lot of these other steps, for much less than that, maybe $3,000 or $4,000 for a new intersection today. So again, there's quite a bit of variability, but hopefully some of those numbers will be of some value to you. I apologize that they're a little vague and maybe not as defined as some of you would like, but that's sort of the experience that we've currently been gathering. So I've taken a little more time than I should. We've got some time left for wrap-up and Q&A, and I'll turn that back over